In this question we're given a formula for distance, and this is going to involve finding velocity and variable acceleration. For part A, we need to find the velocity when t equals 1. Now, velocity is the measurement of the gradient on the distance time graph, and so that is why for part A we will need to differentiate distance with respect to time. So velocity equals ds by dt, which will give us 24 minus 6t squared. Now we need to find the velocity when t equals 1, so we now substitute in when t equals 1. So we'll be given v equals 24 minus 6 multiplied by 1 squared, which will give us 24 minus 6, which is 18 meters per second. We can write it with a slash sign, or we can write it 18 ms to the minus 1. Oops, one error there. It should be centimeters. So I'll change that into centimeters. For part B, the initial velocity is the velocity when t equals 0. So when t equals 0, v will equal 24 minus 6 times 0 is 0, which is 24 centimetres per second. Part C, we need to find the acceleration. Again, the acceleration is the measurement of the gradient on the velocity time graph. So for acceleration, we need to differentiate velocity with respect to time. And so we will get 2 times minus 6 minus 12t. When t equals 1, the acceleration will equal minus 12 times 1, which is minus 12 centimetres per second squared, which you can write like that, or we can write it minus 12 cm s to the negative 2. For part D, find the time when the body comes to rest. The body is at rest when the velocity equals 0. So now I'm going to put the velocity equal to 0. We have 0 equals 24 minus 6t squared. Rearranging this equation, we're now going to get 6t squared equals 24. Divide both sides by 6, giving us t squared equals 4. And so t is going to be the square root of 4, and that is plus or minus the square root of 4, which is plus or minus 2. But to put this into context, we can't have negative time, so therefore the time would be 2 seconds. Now, part E, the distance fallen when the body comes to rest. That means we need to find out the distance when t equals 2. So we need to go back into our original equation, which was s equals 24t minus 2t cubed, and then we're going to substitute into that when t equals 2. So when t equals 2, the distance would be 24 times 2, 48, minus 2 times 2 cubed. 2 cubed is 8, 8 twos is 16, subtract 48, take away 16 is 32 centimetres.